Hi, this is Corey Wooten. I'm going to be going through my code and explaining it and showing its functionality in the debugger. So let's get started. This is my code. I have a couple of variables here. I'm defining the memory location to start at for my write and erase. This is the beginning of the main memory bank 1. I am defining a flash sector location. This is sector 1 in bank 1. So this is what I'll use to start and find where I'm at with my sectors for writing and erasing. I make a data array, 4 kilobytes in size. Then I have 4 different functions that I'll use here. I have 2 delay functions. I have a port initialization function, and then the actual erase and program flash function. So at the start of my main function, I have the watchdog timer being halted while I configure things, and I'm also disabling interrupts. I'm setting the power state to active mode LDO vcore 0. I'm going to use the DCO clock here to set my main clock. So I set that to 3 megahertz, and then I initialize the M clock using DCO clock divided by 1. So it sets it to 3 megahertz essentially. And then from the data sheets of MSP432, I found that I needed to set my wait states of my memory bank to 2, just based on the power settings and things like that. Here I'm initializing the buffer to have data in it. This is the data that's in it, A8. Okay, then I'm going to initialize my ports, so I'm calling that function. In that function, I make P1.0 an output. I believe that's the red LED. Yes, that's the red LED. I make P1.4 an input. That is the switch S2. That's the system reset button that we're going to use. And I enable the pull-up resistor on that. Then I make P2.1 an output. That is the green LED. Okay, back to our main function. We're going to turn the red LED on with this and delay for 1 second. So we have a red LED on for 1 second, and then start the watchdog timer counter here. This makes it 1 second expiration. Okay, then we're going to enter an infinite while loop. So we'll only leave the while loop if the system gets reset with the watchdog timer, but otherwise we'll do this loop. This whole thing will take 1 second, or not 1 second, 1 minute. We're going to do that forever, basically, unless something happens, unless the watchdog timer gets overflowed. So we make a variable called sector, and we're going to set that to 0 and enter our for loop. So we're going to do this for loop 32 times, 1 for each sector in main memory bank 1. And we're going to erase and write to one at a time using this for loop. So we first call the function erase a program flash, so I'll go to that. We first unprotect the flash sector location. We unprotect that location that we defined at the beginning of the program and erase the data in it using this function. Then we reset the watchdog timer counter to make sure we don't overflow. Then we program it with our data of this size. So we're programming what's in buffer for this length. So we're programming essentially one whole sector or 4 kilobytes of data at a time. Then we reset the watchdog timer again and reprotect that sector. Protection means that it can't be erased or written to if it's protected. So we essentially we do that. Then we have this while loop here that if the button P1.4 is held down, or it's also called the switch S2. If it's pressed down and held, we stay in this while loop, and it causes the watchdog timer to overflow just because we're in an infinite loop. So if it lasts more than a second, then we overflow and reset the system. Restart the watchdog timer here for normal functionality, and then here we're going to add a delay. We're doing it in 2 parts because it's more than a second, but essentially we're just adding a delay to make this whole for loop process take a minute if we go through all 32 sectors. And then at the end of the for loop, after we've done one sector of programming, we increment the memory address to move to the next sector in order to program it. Okay, then once we're done programming all 32 sectors, erasing and programming them, we restart the watch timer again and turn on the green LED for 1 second using our same delay function. Let's go down to the delay function really quick. So we're using a 3 megahertz clock, so we had to calculate how many iterations that's going to take, and we calculated that using the event counter in the debugger, and we found that for 3 megahertz clock, to get 1 second delay, this is how many iterations we have to go through. And to do 600 milliseconds delay, we just calculated that using a percentage of this 1 second number. Back to our thing. We turn off the LED, the green LED after the 1 second delay, and we reset to the beginning of the memory bank as to run through the 1 minute cycle again and reprogram all of our sectors again. Okay, so let's go ahead and load it on the board and debug it. I'm going to set up some breakpoints here. So once it's loaded onto the board, I'll set some breakpoints to show functionality of the LED first. So if we run the program, it's going to stop at our first breakpoint, and this is where the red LED is on. So let's go to that location. So the red LED is P1 out, and you can see from this value that it's on. If I run it to the next breakpoint, that value will get changed, indicating that it's off. So that's after the 1 second. If we run to my next breakpoint, actually I forgot to make a breakpoint here, but I'm going to add a breakpoint here and here. So now my program is stopping after writing data to the first sector. So I'm going to show that it wrote data to, it got through a couple sectors before I added the breakpoint, but you can see that data has been written to the first few sectors, and beyond that it's still cleared because I halted the program basically. So we got pretty far before I added the breakpoint. Let's see. Okay, so we got through multiple sectors up to this point where you can see that that it's still cleared here. So I'm going to remove these breakpoints and go through all 32 sectors, essentially let the program run out. And the next breakpoint will be at the green LED, indicating that all 32 sectors have been written to. So the end of the memory bank is just before this location, 40000. So I'll go to that and go up a bit to show that it's empty, it hasn't been programmed yet. Once it gets to our breakpoint, this will have been written to and the green LED will come on. Okay, so now I can see on the board next to me that the green LED is on, so it's written to all of it. At P2 out, we can see that it has this value indicating that the green LED is on. If we run it to the next breakpoint, that will change, and this is a 0 now, indicating that the green LED is off. So we've ended our 1 minute cycle. We've toggled the green LED. We've shown that the red LED can be toggled as well at the beginning if a system reset occurs. And at the end, we just reset to our starting locations so that the 1 minute cycle can happen again. Okay, that pretty much does it for the functionality of the code and running through and explaining it. Now I'm going to move on to actually showing it in real time on the board.